Alright, hey guys, Avi here, and welcome to our new series on Python. In this series, I plan to cover all the basics of Python, from variables to loops to functions, everything. And by the end of this series, you should be up and running with Python, know the basics, and be able to go into any field of Python you want. I've been a developer of Python for over 5 years, and I know what it's like to start from the beginning. I remember when I was 10, 11, I was writing my first Python script, print hello world, and it was fantastic. But what you can do with Python is tremendous. You can create games, you can parse websites, you can use data, manipulate it to do whatever you want. Python has tons of modules, tons of fun stuff for you to do, and I'm glad you've chosen Python. So let's get started. The first thing you need is to install Python. Let's go ahead and search for Python in our Google browser. You're going to select the first link. It's going to be from python.org. And over here, if you scroll down, you want the latest version, Python 3.5. If there's a new version of Python when you're watching this video, just download that. Hopefully things aren't too different. Python 2.7 also exists, but again, I like using the latest version. If you scroll down on the downloads page, you should be able to see the different downloads that exist. There's some for Mac, some for Windows. It's all up to you, whatever computer you have. Go ahead and select the download file and your download should start installing. I've already installed Python, so I'm not going to do that, but just go ahead and get that started. When you're done, open up your applications, open up the folder where it is. You'll be working in an IDLE. Now, I personally don't like Python's IDLE. As you can see, this is Python 3.5. It's nice, alright, it's very functional, it has a lot of things you can do with it, but I personally don't like it. So what we're going to be doing is we're going to install our own IDLE, and the one we're going to be installing is PyCharm. If you guys know what PyCharm is, that's fantastic. It's by a company known as JetBrains, and JetBrains has a ton of software. Now, if you're a student like I am, you can get the premium version of PyCharm for free. Just search the JetBrains Student Developer Program on Google, and it should guide you through the process of getting PyCharm premium version for free. Also, PyCharm has the community version in case you're not a student. So go ahead and download. It's going to ask you, hey, are you getting the community or the professional? Again, if you are a student, you can get the professional. Otherwise, just go ahead and get the community version. Alright, so now that you've installed PyCharm, let's go ahead and open it up. Now, you should probably have it wherever you installed it. I have it right over here, so I'm going to go ahead and select it. This is the PyCharm interface. You have PyCharm, the previous projects that you have on the left-hand side. You can create a new project, you can open, version control, all sorts of stuff. I'm going to go ahead and create a new project. I'm going to say code/python, and I'm going to call it hello world, like everyone else does. Our interpreter should be our 3.5 version, right over here, or 2.7 if you install 2.7. Go ahead and select 3.5 and hit create. Fantastic. So this is our hello world project. I'm not going to talk too much about how PyCharm works and stuff, but if you select this, there's nothing in it. So right click on your hello world project, say new Python file, and call it helloworld.py. Awesome. And inside of this, I want you to type one simple command, print hello world. Save this, and let's go ahead and run it. If you're on a Mac, you can do Control-Shift-R, and if you're on a Windows, you can hit the run over here, or just find a way to run the project. It should be very simple and fantastic. We got hello world printed on our console. This is it, guys. This is our getting started Python video. Don't forget to like, share, and subscribe. Alright, Avi here, and welcome to part 2 in getting started with Python. Now, we left off where we got our print statement down, we had PyCharm, Python, both installed. Now it's actually time to start writing Python. So the first thing we're going to talk about is variables. Alright, what are variables? How do we initialize them, store values, all that good stuff. So what is a variable? Well, hopefully in any other programming language that you might have dealt with, you know what variables are. Variables are basically memory locations to store values. If my friend is turning 20 years old, alright, I want to store that value, 20, in a variable. I can do that. Let's say I'm stating that my name is Avi. I can store that sentence, that string, in a variable. All variables are, they're just data. They're just memory locations to store values. So how do we do that in Python? Well, let's take a look. So instead of writing in this file where we'll normally write code, just for simplicity, we're going to be using the Python console. Now, if you don't see the Python console like this down below, what I want you to do is hover over this sort of menu icon in the bottom left of your screen. And you'll see a menu with a list of different things you can open. And we want to open the Python console. So immediately you can see the Python console has opened. Now yours might be a bit below. Just go ahead and drag it up. So to initialize a variable in Python, there's 3 steps. The first step is the variable name. In other languages, you have to write var, init, all of that random stuff before the variable name. There's none of that. It's just the variable name. So we're talking about my friend. He's turning 20. We're going to write age. And I like lowercase, so age. Okay? The second step is an equal sign. You have to assign your variable to a value, and you do that through an equal sign. So age equals. And then finally, you write the value. In this case, he turned 20, so we're going to say age equals 20. Hit enter. And now, age, the variable, has been assigned the value 20. If we type age in the console, we get the value 20. Fantastic. Now let's go back to the sentence, my name is Avi. I want to store that sentence in a variable. So I'm going to create a variable called sentence, hit equals, and in quotation marks, because it's a string, I'm going to say my name is Avi. Go ahead and
enter. And now that string, that sentence, has been assigned to the variable sentence. So now if I want to take a look at it again or view the data inside the variable, just type it, hit enter, and you get my name is Avi. Fantastic. That's all there is to variables. So you assign data, you can print it, you can use it in various methods. We'll cover that in later lectures, but all I wanted you to understand is how to create these variables. Now, Python also has a neat feature known as multiple assignment. Suppose I have a bunch of friends whose birthdays today. One's turning 16, another's turning 18, 3 more are turning 21. Doesn't matter. Based on what we know right now, we'd say, let's say Sarah's age, she's turning 16. Bob's age, he's turning 21. Mike, he's turning 17. This is tedious, right? We have to create a new variable on every line. But with multiple assignment, in one line, you can assign the values to all the variables. The way that works is very simple. I want to assign Sarah, Bob, and Mike the ages 16, 21, and 17 respectively. What I say is Sarah, Bob, Mike is equal to 16, 21, 17. Alright? In this case, Sarah is getting the value of 16, Bob is getting the value of 21, Mike is getting the value of 17. Hit enter. And now if I want to say Bob's value, I get 21. If I want Mike's value, I get 17. That's the way multiple assignment works. Instead of having to do it on every individual line, you can get all your variables populated in one single line. Now suppose you had 10 friends who were turning 17 today. Instead of having to do this 10 times, one variable for each person, and then 17 10 times, you can assign each variable the same value by saying Sarah is equal to Bob is equal to Mike is equal to 17. By doing so, each one of these variables has been assigned the same value, 17. So now if I say Sarah, I get 17, Bob is 17, and Mike is 17. That's the power of multiple assignment, to make your Python code swifter and easier, right? You don't have to go through the process of multiple declaration in every line. It's all in one line. Nice and easy. So for a quick challenge, let's go ahead and try something out. I want you to create in one line 2 variables. One should be your age and one should be your name. The first one should be a normal number like we've discussed, and the other one should be a sentence. So using this multiple assignment, go ahead and give it a try, your name and your age. Alright, hopefully you're able to do it. If you weren't, don't worry. We're just getting started. So I'm going to go ahead and say name, age is equal to. Now the first one, since it is a string, I have to put it in quotation marks. And I'm going to say Avi, and then I'm going to say my age, 15. Awesome. So now let's go ahead and check the values, name, and age. Great. So that's it for this lecture. A quick recap. We learned what variables are. We learned how to initialize them. There are 3 parts. You have the variable name, an equal sign, and the value. And then we learned about multiple assignment and declaring multiple variables in one line. Don't forget to like, share, and subscribe, and I'll see you in the next video.
Hey guys, Avi here, and welcome to part 3 in getting started with Python. Now, we left off where we talked about some basic Python structure, what variables are, how they work, and now it's time to move on to arithmetic operators. So if you don't see this right now, just open up PyCharm. If you go to the bottom left-hand side, look in your menu, and you should see Python console. Select that, and you should see this nice big console right over here. For the time being, we'll be working in this until we start writing more extensive code. Alright, so let's get started. Now, hopefully you've dealt with arithmetic operators before, maybe in algebra, geometry, wherever you learned them in math, and they're very simple. You have addition, subtraction, multiplication, division, and modulus. Alright, now I'm pretty sure you know what these arithmetic operators are, but today I'm going to be talking about how they apply to variables. So let's say we have two friends, alright? One's age is 12 and the other is 18. So let's go ahead and create two variables. One's going to be age 1, and that's going to be equal to 12. And the other is going to be age 2, and that's going to be equal to 18. Alright? So now we have two variables, age 1 and age 2. And in this video, in this lecture, we're just going to talk about how we can manipulate them. What can we do with these variables? Well, since they're integers, they're numbers, we can use the arithmetic operators of Python to play around. So I can say, for example, if I want to know what's the sum of both of these people, I can say age 1 plus age 2. Alright, exactly, 30, 12 plus 18. Let's go ahead and try subtraction. Suppose I want to find out what age 1 minus age 2 is. I get negative 6. Fantastic. Let's go ahead and try out the rest. We have multiplication, and for multiplication, instead of our normal x, which we denote as times, we'll be using the asterisk. The asterisk is Shift 8 on your keyboard. That's what normally denotes multiplication in most programming languages. So age 1 into age 2, that gets us 216. Let's go ahead and say age 1 divided by age 2. That gives us 0.66, and again, the divided is the /. And then we're going to talk about modulus. So modulus is basically a function that gives you the remainder. For example, we did age 1 divided by age 2 over here, and we got a decimal, right? If we don't want the exact answer and instead we want the remainder, we can use the modulus. So let's try it out. Let's go ahead and say age 2% age 1. Again, using the percent sign, we get 6. And if we try age 1% age 2, we get 12. Alright? So that's basically the remainder. If you divide age 2 by age 1, what's the remainder? 6. And if you divide age 1 by age 2, what's the remainder? 12. It's by itself. Alright, now that we've finished talking about arithmetic operators, let's go ahead and move on to strings. Now, we've dealt with strings before. We know what sentence is, how to create them, the print hello world. Those quotation marks, the content inside those quotation marks are strings, okay? So let's go ahead and say sentence 1 is equal to, today was a beautiful day, okay? A very simple sentence, can be anything you want, and that's it. So what we have here is sent1 is a string. That's its data type. We know that integers, age 1, age 2, they're the numbers. Strings are the things in quotation marks, the words, the characters. So let's go ahead and test out the operators we've learned with these strings. Suppose I have a first name and last name variable, okay? And my goal was to add them together to get my full name. Let's go ahead and try that out in Python. Well, first we need our first name variable. First name is equal to Avi or Avinash, and then we need our last name variable. Last name is equal to Jane. Alright? You can do the same for yourself, first name, last name, and now it comes to add them together, to concatenate them. And it's just like we learned with arithmetic operators. Age 1 plus age 2, first name plus last name. And what do we get? Avinash Jane. Except there's no gap. And honestly, if there is no gap, it looks very crude. So let's go ahead and add a small gap in between. We can do this multiple ways, but an easy way is just to say first name plus a space plus the last name. And that gives us a gap between Avinash and Jane. Alright? So just like we could add integers, add these numbers up over here, you can add strings the exact same way. Now, I'm pretty sure you're wondering, well, can you subtract them? No, you can't. I'm sorry. You can try first name minus last name, and we get an error. You can't subtract a string and a string, because that doesn't make sense. However, what you can do is multiply a string with an integer. Suppose I wanted to list out hi 10 times, alright? I have my string hi, and I'd like to list this out 10 times. Let's go ahead and say hi into 10, and we get hi 10 times. That's how you can use our strings with the arithmetic operators that we've learned. Now, hopefully you can think about it. Division doesn't work with strings, and modulus doesn't work either. But the two operators that you can use are addition, adding two strings together, and multiplication, repeating a string multiple times. Now, one last thing before we end this video, and this is a really neat concept. Okay, let's go, just hang with me for a few more moments. I'm going to create a sentence, and it's going to be a bit long. I'm going to say, Avinash was playing basketball, okay? And this is my sentence. I have a string, it's a sentence, and all I want is my name, okay? I don't want was, I don't want playing, I don't want basketball, I don't want the gaps in between. All I want is my name. This is where a really neat feature of Python comes in. Every character gets an index, okay? Every character of a string in Python gets an index. And I know what you're thinking. You're probably thinking, alright, so this must be 1, V must be 2, I must be 3, N must be 4, and so on. Well, in programming languages, that doesn't happen. Instead, the indexes start from 0. So what I want you to think is, in this case, A is 0, B is 1, I is 2, N is 3, and so on. So all the indexes that you currently think about, subtract 1 from them. So suppose I want the first character, alright? Let's go ahead and say sentence, and then in square brackets, go ahead and put the integer 0. This basically means get me the character at index 0, and I get A, alright? What we're doing here is we're doing a function known as splicing. We're taking our string and we're getting a specific segment of it, splicing our string. Suppose I want to get the fifth character. I know that the fifth character is actually 4 in terms of our index. So I can say sentence 4 is A, the lowercase a, right over here. Now let's go ahead and talk about how do we get all of the 7 characters. We don't want 1, we don't want 1, 1, 1, 1. We want all 7 of them. Well, we can do that again through splicing. We can say sentence, and then in square brackets, we want to start from the very beginning, 0, and then we want to go all the way up till character 7. So let's go ahead and try this out first. 0 to 7. What do we get? We get Avinash. Fantastic. Now I know what you're thinking. We started off at 0, which made sense, but shouldn't the 7th character have been the space over here? 0, 1, 2, 3, 4, 5, 6, 7, right? Except with splicing, you have to remember that when you do this sort of splice, when you take an initial position and an ending position, Python doesn't count the ending position, all right? So when you actually say from 0 to 7, Python is actually splicing from 0 to 6. So if I try saying sentence 0 to 6, I'm only going to get Avinash. I'm not going to get the H at the end. So this is just one of various things you can do with splicing. You can say sentence, if I want to get, I don't know, let's see, I want to get the first 3, I can say :3. If I want to get maybe, you can use negative numbers too. I could say sentence :-2, and I'll get everything but the last 2 characters. So splicing is definitely useful in Python. You can take any string and you can get a specific segment out of it, a specific splice. Alright, let's do a quick recap of what we learned. We started off with the mathematical operators. We have plus, minus, multiply, divide, and modulus. Remember, modulus is remainder. We then moved on to strings, and we understood that you can apply two of these arithmetical operators to strings, addition and multiplication. And then last but not least, we learned about splicing. We learned that every character has an index, and the index actually starts from 0. So the first character is 0, second is 1, and so on. And then we learned that we can get a segment of the string, numerous characters, by using a format like this. Your first position, colon, your last position plus 1. Because remember, Python doesn't count the last index when you put in for the splice. Alright guys, thank you so much. Don't forget to subscribe, like, and share this video, and I'll see you in the next lecture.
Hey guys, Avi here, and welcome to part 4 in Getting Started with Python. Now, we left off where we had covered integers, strings, variables, and today we're going to cover a very simple concept of Python, which is known as placeholders. Now, hopefully you know what placeholders are. They basically stand for taking the place of something. So let's say I had a friend Jake, okay? I'm going to say name is equal to Jake, okay? And I want to say that today is Jake's birthday. All right, or Jake is 15 years old. Let's take that. Jake is 15 years old. So one way I could do it is say name plus is 15 years old, right? That's absolutely fine. Or I'm sorry. Name is equal to Jake, and then we say name plus is 15 years old. And this works fine, right? We get the sentence, Jake is 15 years old. However, there's an easier way to do this, okay? And that is using these placeholders. We put a placeholder inside a string to refer that, hey, instead of the placeholder, go ahead and put this variable. It could be an integer, it could be another string, doesn't matter. But every placeholder signifies a specific data type. So let's go ahead and create a variable called sentence and set this equal to is 15 years old. Now, obviously over here, we want to say the name should come, and we specify a string placeholder by using %s, okay? Cent is equal to %s is 15 years old. That's great. Right now, if you print cent, we're going to get %s. However, when you use the placeholder syntax, %s will be replaced by a variable. So go ahead and say cent percent, so get it, cent percent, and then in brackets, or I think just using name, you should get Jake is 15 years old. Awesome. I could substitute it for anything. I could say cent Avi. Forgot the % sign. Avi. Hit enter. Avi is 15 years old. Basically, you use the % sign to signify that it is a placeholder. So you say %s to signify what type it is and where it should go in the sentence, and then you signify that you want to substitute the value by saying % and then whatever value you want to substitute it with. Now, I know what you're thinking. What if there's multiple things? Right now we've only dealt with one. What if there's two variables? Barack Obama is the president of the United States, right? So cent is equal to %s, Barack Obama, 2 words, is the president of the US. That's probably going to change in the next 6 months due to elections, but as of right now, he is the president. And now we can go ahead and set both values by saying cent %, and then in brackets, both the values separated by comma. Barack, comma, Obama. Hit enter, and we get Barack Obama is the president of the United States. And you can see how this can be useful, all right? You don't have to use the plus, this string, watch out for the spaces. These placeholders will just be replaced by the variable values. Let's go ahead and talk about integers. What if I want to add an integer, all right? Jake is X years old, except I want to specify both the person and the age. Well, let's go ahead and create a new cent and set it equal to %s for the name is %d for the integer, all right? S is for string, D is for integer. %s is %d years old. So that's our sentence. And now any string and any integer can take place of the %s and the %d respectively. So let's go ahead and say something like %s percentage in quotation marks for the first one, because obviously we have to refer to percent %s first. We can say, I don't know, Obama, and then let's go ahead and say, I believe he's 50. I'm probably wrong. Whatever. Send percent Obama, comma 50. And now we get Obama is 50 years old. So this is basically what placeholders are. Again, I know this is a short lecture, but I just wanted to touch base on this topic. You have placeholders to be in sentences, to be in variables, which then are replaced by other variables. So you can see how you can use them in different cases. You have to set someone's score, you have to set someone's age. You can use placeholders to do that. Quick recap, placeholders are created using percent signs. Percent %s stands for string, percent %d stands for integer. You can set a placeholder by saying cent, or whatever your string with those percentages are, percent sign, and then in brackets. And I can even set this to a variable. I could say cent2 is equal to whatever cent1 is. Let me see if this works. Yes, it does. Or yes. So cent percent Barack Obama, cent2 is equal to this, and it gives me, we replaced it. So let's go ahead and put 50, and now if I say cent2, that value has been stored. So placeholders are awesome. Go ahead and play around with them. Don't forget to like, share, and subscribe, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our Python development series. Now we left off where we covered what strings are, what placeholders and strings are, all that good stuff. In today's lecture, we'll be tackling one of Python's first data structures, which are Python lists. Okay? So first thing first, what is a list? Well, generally, what do you think of when you think of a list? It's a set of items that are ordered, they have an index, you know what each value is, and that's basically the same case for a Python list. It's a comma-separated value that allows us to access any item based on its index. So let's say I'm going shopping, okay? I want to create a shopping list in Python. I want to get apples, oranges, bananas, and cheese, okay? Now, one way I could do this is by associating each item to a variable. I could say item 1 is apples, item 2 is oranges, item 3 is bananas, item 4 is cheese. And yes, that works, but if you think about it, you don't want to create tens of hundreds of variables because that's inefficient. Instead, we have lists. So take a look. So I have apples, oranges, bananas, and cheese in my list, and this is the syntax. You start with a square bracket, have your 4 items separated by commas, and then you close it with the square brackets. Now, this part over here is for the variables. Yes, I could have done the variables, but instead, let's X this, and we're going to use a list. One key thing that you have to remember about a list is that the indexing is off by 1. What you guys might think as the first item, which is apples, is actually index 0 in the list because counting starts from 0. So if I want the second item in my list, I'm not going to say list 2, I'm going to say list 1 because the second item in our list is actually the first index position. So let's go ahead and create a list and everything will make sense soon. So I'm going to go ahead and call this shop list. And again, square brackets, every item separated by commas. So these are strings again, apples, oranges, bananas, and cheese, okay? So now we have our shop list. If you go ahead and print this out, you'll notice that this is the array format, and every item is separated by commas. Now how do I access a value? Well, we just discussed that the index is off by 1. So if I want the first item, I say shop list 0. Well, it's very straightforward. All I have to do is say shop list, and then in square brackets, put in your index. So I want the first item, I say shop list 0, I get apples. I want the third item, I say 3 minus 1, 2, shop list 2, bananas. Third item or fourth item, then I say 4 minus 3, 1, that's 3, shop list 3 gets me cheese. Now, one cool thing about PyCharm or almost any IDLE is that if you want to go to a previous line of code that you've written, you can always use the arrow keys to go up and down your code. For example, if I want to use the same line of code for my shop list 3, I just hit the arrow key up and I get that code and I can modify it, do whatever I want. Awesome. So this is one way you can access your items in an array. There's also splicing in arrays. I can say shop list 0 to 2, 0 to 2, and this will get me apples and oranges. It's very similar to what we discussed before. Instead of it takes the first parameter, which is 0, it goes to 1, and then it doesn't count your end range. So it says 0, 1, whoops, we don't count 2, it stops. If I want to get the first 3 items, I'll say shop list 0 to 3, it says 0, 1, 2, whoops, we hit 3, stop. So that's how we access values in lists. Now we want to update it. Say we're talking to our parents or we're talking to someone and they're like, oh, go ahead and get me blueberries as well. How do we add items to our list when we've already created it? Well, one nice thing about lists is that they're mutable. You can add objects, you can append, delete, do a lot of functions, a lot of different methods with lists. So what I'm going to go ahead and do is add an item to our list. And we use the append function to do that. Shop list.append, and I'm going to go ahead and append blueberries, okay? Now, if I print out shop list, you're going to notice that blueberries has been appended to the end of our shopping list, which is exactly what we wanted. But now let's say, oh, we no longer need apples, we actually need cherries, okay? There's been a mass shortage of cherries, we want cherries now. How do we change that? Well, there's another way we can do this. We can go ahead and say shop list 0. So the item at the first position of our list should be equal to cherries, okay? Go ahead and understand the syntax. We're basically saying that whatever item exists at this position, update its value to cherries. So now when I say shop list, instead of apples, I get cherries, oranges, bananas, cheese, blueberries. So that's one way you can update values in an index, and the append method allows us to add objects to our array or to our list. Now let's say, okay, we've done all of this, but guess what? We no longer need oranges because no one likes oranges, all right? How do we delete items in our list? Well, one way you can do this is by using the delete method. You say delete using del as the method name, and then you say shop list, whichever index, whatever you want to delete. I want to delete oranges, and I know that's index 2. Oh, I'm sorry, that's index 1. So go ahead and say delete shop list 1, and now when I say shop list, I get cherries, bananas, cheese, blueberries. Oranges has been removed from our list. All right, so what have we covered so far? We've covered how to add to an array, how to create an array, how to get in position of an item in an array, and how to delete an object in an array. Now, there's a few more cool things you can do with arrays. Just like we learned the arithmetic operators, you can use the same things for arrays. You can go ahead and add arrays, you can multiply arrays. Let's go ahead and see how they work. First of all, let's go ahead and see how many items are in my shop list. And I can do that using the len function. The len method returns me how many items are in my list, no matter what. Okay, so there's 4 items in my list. Now let's say I had another list. I'm going to call this shop list 2. And this is going to have, bread and jam and peanut butter. Okay, and I want to combine these 2 lists together. What I can do is say shop list plus shop list 2. You can add array lists, you can add lists together to create one big giant list. Another thing you can do is multiply lists. You can say something like, if you want to repeat values multiple times, you can say shop list times 2. And that repeats the values in shop list once and then twice. So these are just some of the arithmetical operators that you can use in lists. They're very basic and they're very straightforward. Adding lists together, finding out if you can multiply lists. 2 more functions I want to touch base on before I end this lecture, and that's max and min. Suppose we have in a list of the greatest of a few numbers. I'm going to call this list num, and I'm going to go ahead and populate it with some numbers. 1, 4, 5, or 7, 23, and 6, okay? If I want to find the max of list num, find the biggest number there, I can call the max function on our list num list. And if I want to find the smallest value, I can say min of list num. Awesome. So in this lecture, we touched base on lists. We covered what they are, how to create them, indexing, appending, deleting, mathematical operators, and then last but not least, the max and min functions. Now there's many more things you can do with lists, but just as a quick introduction, I hope lists made sense to you. Anyways, that's it from my side, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our series on Python programming.
Now, we left off where we just talked about lists, and in today's lecture, we're talking about dictionaries, a new type of data structure. Now, what is a dictionary? Well, let's take an example. Let's say that we have students in a classroom, and every single student has a name and an age. If you want to store this information in a list, we'd say something like students is equal to, and then in square brackets, each student's name, and then their age. So Bob 12, Rachel 13, and Emily 15, okay? This works, right? We're storing every student's name and age one after the other, but it's not effective. If I want to find out what Rachel's age is, I first have to find out where Rachel is in the list and then find the value next to it. That's not effective, that's not efficient. We shouldn't be using a list data structure in this scenario. That's where dictionaries come in. If you guys have ever seen a map and every single legend on the map, you know how green is land, blue is water, so on and so forth, where each symbol has a value. Well, that's the core principle of a dictionary. Every dictionary has a key and a value. When you try to access the key, you get the value of that dictionary. Pretty straightforward. So let's go ahead and use this exact same data we made for a list and make a dictionary out of it. So I'm going to go ahead and say students is equal to, and then create a dictionary, use curly brackets. So students is equal to Bob, then colon 12, okay? So Bob is the key and 12 is the value. The next one is Rachel, colon 13, and Emily, colon 15. Awesome. So this is students dictionary. Each key is the name, each value is the age. If I print out students, I get Emily 15, Bob 12, Rachel 13. Awesome. Now, the next thing is accessing one of the values. Now, I want to find out how old Rachel is. How do I do that? Well, I'm going to say students, and then in square brackets, the key. In this case, the key is Rachel. So students Rachel, that gets me her age, 13. Let's do the same thing with Bob. Students, and then square brackets, quotation marks, Bob, I get 12, okay? So that's the core principle of dictionaries, how you create a dictionary, how you access a value of the dictionary. Now let's say that Rachel is now 15. I want to update her age. How do I do that? Well, the exact same way we access her age, students, Rachel, all we have to do now is set that value to a new value. So students, Rachel is equal to 15. Now, if I print out students, I see that Rachel is now 15. So that's one way you can update a dictionary. Another way to delete items in a dictionary, let's say that Emily left the school. How do I remove that sort of key value pair from the dictionary? One of the functions is the del function, the del, and then all I have to do is say my dictionary name and then what key value pair, or in this case, what key am I trying to remove? I don't want to have Emily anymore in my dictionary. So I'm going to say del students Emily, and that removes the Emily key and her respective value from the dictionary. So now I have Bob and Rachel. A couple more functions in dictionaries. You have the len function. So you can find out the length of your dictionaries by calling len and then in brackets your dictionary name. So I find out that there are 2 items in my dictionary. And one last thing about dictionaries that you guys should know is that you're not supposed to have multiple keys that correspond to different values. So if you have the same key over and over again, let's say you have 3 Bobs in the classroom. I'm going to create a new students array. I'm going to have Bob 12. Let's say we have another Bob, his name age is 14, and another Bob, and his age is 16. You're not supposed to have a dictionary like this. Each key should be unique, because now if I try to access Bob's age, Python doesn't know which Bob we're talking about, and it automatically uses the last key that we entered. So if we have Bob 12, Bob 14, Bob 16, Python's going to realize that, hey, the last key Bob was this one, and its value is 16, so it's going to return 16. In most cases, when you're dealing with dictionaries, you want each key to be separate so that problems like these don't arise. But anyways, awesome job for this lecture. Quick recap, you're using dictionaries when you have a key and a value. When you have sort of like in legends or maps, you have a symbol and that symbol is associated with value. Exact same case over here. You can see your dictionary just printing it out. You can update the values by changing what the key corresponds to. You can delete values in the dictionary, figure out how long it is, and also understand that you should have different keys throughout your dictionary. Don't repeat your keys in the dictionary because that's not proper programming practice. Anyways, awesome job in this lecture. If you have any questions, don't forget to ask below. Like, subscribe, share, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our Python series. In this video, we're going to learn what a tuple is. Now, tuples are the last data structure we're learning, and the core concept is that they're the exact same thing as lists. They're a sequence, but most of all, they're immutable. They can't be changed. You can't delete items in a tuple. You can't update items in a tuple. Once a tuple is made, it's there forever. So how do we create a tuple? So the basic concept is right here, is you say tup1, or in this case just tup, is equal to normal parentheses. Not square, not curly, just the normal round parentheses. And then you populate it with whatever list items you want. Let's say oranges, apples, and bananas. All right, now if I enter, we've created the tuple. And if I want to print it out, there we go, oranges, apples, and bananas. Now again, the most important thing about a tuple is that you can't update it. So if I want to, say, hey, tup, oranges, or tup0 should be now cherries, it's going to give me an error saying that tuple does not support item assignment. But what you can do is you can access the values. So just like I did over here, tup0, you can access the values just like in a list. Tup0 gets me oranges, tup1 gets me apples, so on and so forth. And the exact same thing with the index splicing that we learned with lists. If we have tup0 and we go 0 to 2, we get oranges and apples. So all those functions that we use in lists still work. It's just that you can't update or change what a tuple has been created with. That being said, however, you can add tuples together. If I create another tuple, tup2, and I add a few numbers here, 12 and 14, and now I want to create a new tuple with tup and tup2, then I can go ahead and say tup3 is equal to tup plus tup2. Okay, so by doing that, I can create, by doing that, I can add multiple tuples together, but again, still reinforcing the concept that you can't modify or delete a tuple that already exists. What you can do is you can delete a tuple, the entire thing, by calling del and then the tuple name. So I'm going to go ahead and delete tup3, and that removes tup3 from our code. It says tup3 is not defined. But you can't actually remove specific items inside of your tuple. Other than that, that's basically the core concept of tuples. We still have a len function like we learned in dictionaries. You can call len of tup, and we can get how many items are in the current tuple. And what you can also do is you can use the string functions that we learned, for example, repetition. You could say something like if tup is equal to hi, then I can say tup times 4 to get hi. I can also add tuples. We learned that already, concatenating them, creating multiple tuples. But just remember, tuples are immutable. So quick recap of this video, guys. Tuples are another data structure in Python, and the core concept is they're immutable. You can't change them. They work just like lists. They're a sequencing sort of data structure. You can create a tuple using normal parentheses. You can access them using the current index strategy where you have square brackets and then a number. You can still splice them, going from 0 to 2, 0 to 1, stuff like that. And you can also concatenate and multiply them. Just remember, you can't delete tuples, or you can't delete items in tuples, and you can't modify them. They're immutable. Thanks for listening, guys. That was tuples in a nutshell. Don't forget to like, share, subscribe. If you have any questions, ask down below, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our Python series. In this lecture, we're going to be learning conditional statements. Now, the core concept of conditional statements is an if and else case. If something is happening, we want something to happen. Otherwise, we have an else case where something else happens. While that may seem confusing, let's go ahead and take a practical example. Let's say it's raining outside. If it's raining, I'm going to take an umbrella. If it's not raining, I'll wear shorts. Something as straightforward as that basically defines what a conditional statement is. You have the concept of true and false, and if something is true, the if code will run. Otherwise, if that statement is false, then the false code will run. So let's go ahead and give a quick example of how if statements work. So over here, I'm going to go ahead and say if 5 greater than 3. Okay, so notice how I used these parentheses, and then inside of that I put a statement. This statement has to result to either true or false, okay? It has to give me some sort of output, which is a Boolean value, either true or false. If 5 is greater than 3, colon, now I'm going to hit enter, and it gives me the next line. So if this statement, 5 greater than 3, is true, I want something to happen. Now I'm going to go ahead and say that I'm going to print hello. Okay? That's perfect. Hit enter, and I get hello. So this is the core foundation of conditional statements. If this statement, 5 greater than 3, is true, I want to print out hello. What if this condition is not true though? What if we put a false condition? I'm going to go ahead and say if, I don't know, 3 is less than 2. Obviously it's not, colon. Then I want to say print hello, okay? Otherwise, so I'm going to shift tab. So notice how our cursor right now is at print. If you hit shift tab on your keyboard, you go back, okay? We want to go back one statement, and we want to say else. So if this condition, 3 less than 2, is not true, then I'm going to print out the condition was not true, okay? And now I get the condition was not true. So one thing I want you guys to really notice right over here is that Python is very dependent on where you type your code. Your if and else statements have to be on the same line. That shows that this if and this else are together. They're one block of code. And then the functions for each if and the function for each else has to be one tab to the right, or 4 spaces, whatever you guys choose. So if 3 is less than 2, tab, print hello, else, and then we have this gap over here, print the condition was not true. That's very, very important, okay? So now continuing on, these conditional statements have operators, okay? We have greater than, we have less than. There's also various relational operators in Python. I'm gonna go ahead and quickly show you a couple of them. So we have 3 greater than or equal to 2, okay? That's true. We have 3 less than or equal to 2, that's gonna be false. We have 3 equal to 3, okay? So when you're comparing objects in Python, for example, it could be variables, you could be comparing numbers, you could be comparing strings, you use the double equal to sign. I know what you guys are thinking. What if you use a single equal to sign? What if we say 5 equal to 3? What happens then? We get an error. Python uses the single equal to sign to assign a value. When we say a variable name, and equal to avi, we assign the value avi to the variable name. But if you want to compare two values, if you want to compare a number to another number, then we have to say 2 equal to's, and then any number 2, okay? And the last relational operator is not equal to. If you want to check if two things are not equal to each other, we use an exclamation mark and then an equal to sign. So 3 not equal to 2, we get true. So just to quickly recap on the 6 relational operators, you have greater than, you have less than, you have greater than equal to, you have less than equal to, you have equal to, which is basically compare to, and then we have not equal to. So these are your 6 relational operators. And the last thing I want to cover in this lecture is elif. Say we have a number and we have different ranges. I'm going to go ahead and create an age variable, set this equal to 16, okay? Now I'm going to go ahead and say, if my age is less than 13, if my age is less than 13, I'm going to say print out you are young, okay? Now I want to create a condition for when my age is between 13 and 18, okay? Right now, all we know is if and else. That's where elif comes in. Elif basically acts as another if statement. Elif stands for else if. So I'm going to go ahead and say elif, age greater than or equal to 13, and, okay? So this is very key. This and basically means we're combining both conditions together. If age is greater than or equal to 13 and age is less than 18, I'm going to go ahead and say print you are a teenager, okay? And then else, I'm going to go ahead and say print you are an adult. Okay, so quick thing to know over here, guys. Remember, just look at this placement of the if, elif, and else. They're all in one line. And then the functions are all in one line. Make sure yours look exactly the same. Otherwise, you will get an error. And make sure that you have your colons after your if and elif. Most people forget to do that. Hit enter, and I'm going to get you are a teenager. So in conditional statements, you also have this concept of ands and ORs. ANDs basically combine both conditional statements. If I say if 5 is greater than 3, so if 5 is greater than 3, and 2 is greater than 1, print high. I'm gonna get high because both of these conditions return true. However, with OR, what you can do is say if 5 is greater than 3 and 2 is less than 1, which is false, print high, we're still gonna get high because if 5 is greater than 3, oh, I'm sorry, I used AND. Okay, so if 5 is greater than 3, I'm gonna make this OR and print high. We're still gonna get high because of the OR condition. What OR does is it basically checks both conditions, and if one of them is true, just one has to be true, then it will result the entire condition to be true. So there's two main sort of these comparators, AND and OR, and make sure that both of the conditions are true, or just checks to see if one of them is true. Alright, so let's do a quick recap of conditional statements. First of all, there's if and else. If some condition is true, perform a function, else, which is basically the backup option, do another function. You have 6 different relational operators: greater than, less than, greater than or equal to, less than or equal to, compared to, and not equal to. Okay? Those are your 6 relational operators. Elif basically allows you to have multiple if statements. You can say if, then elif, 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 and then always have a backup option, else. Okay? And then last but not least, we touch base on and OR. And make sure that both conditions you're comparing are true, and OR makes sure that at least one of them is true for the entire condition to be true. Anyways, thanks for listening, guys. Hopefully conditional statements made sense to you. Don't forget to like, share, and subscribe, and I'll see you in the next video. Hey guys, Avi here, and welcome back to your Python series. In this video, we're going to be learning about for loops. Now, the core concept of for loops is that you're iterating over something, whether that be a data structure or a series of numbers. Now, we've talked about lists, we've talked about tuples, so I'm going to go ahead and create a list, call it list1, and I'm just going to populate it with some fruits. You know, what we've been doing before: apples, bananas, and cherries. Okay? And I'm also going to create a tuple, top one, and I'm going to go ahead and just put in some numbers. Doesn't matter, it can be anything. It's just to show you guys how to iterate over these data structures. Now, let's say I want to access every value, or I want to print out every single value in my list. What am I going to do? I'm going to use a for loop. I'm going to say for, and then the next thing you write over here is going to be the variable name. What do you want each item in your list or in your tuple to be known as? I'm going to call mine item. For item in list 1, colon, okay? So for item in list 1, I want to print out item, okay? So again, looking at this code, it's very straightforward. Thinking about it literally, you're just going over every item in the list and you're printing it out. Hit enter, I get apples, bananas, cherries. Awesome. So what exactly happened here? The for loop iterates over every single item in the list. It goes to the first one. It says, okay, the value is apples. I'm assigning this value apples to my variable item. And then in the code, it says print item. So it's going to print out apples. Then it goes to the next item in the list, bananas. For item in list 1, okay, so we're at bananas, item is now bananas, print bananas. So it prints out bananas, and it does the exact same thing for cherries. Now let's go ahead and print out our tuple. For top, or sure, we can do item again. For item in tuple 1, colon, print item, okay? So if I iterate over a tuple, it's the exact same concept, 13, 12, 15. So that's one way you use for loops, to iterate over a specific data structure, get each item, and then maybe do something with it. Maybe you want to find out what's in the list. Maybe you want to add stuff to it. Maybe you want to change stuff up. Doesn't matter what it is, but for loops are very effective in iterating over a data structure. The second reason why you might want to use a for loop is to iterate over numbers. Now, we haven't talked about functions yet, and I plan to do that in a future video, but for loops you can use a for loop with something known as a range function. The range function gives you basically a series of numbers starting from one index going to another index. So let's take a look at how this works. Most of the time when you use a for loop with the range function, I use the variable I. It's just one of those things, you say for I in something, but you can use any variable name you want. Just remember what it is. So for I in range, okay? After range, go ahead and type 2 parentheses, again, shift 9, shift 0, and then you're going to specify the initial index and the ending index. So I'm going to say from range, so for I in range 0 to 10, print I. Okay, I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So one thing that's key about the range function is that it doesn't go to the second index you specify. It goes to one less. If I want to print out the first 10 numbers from 1 to 10, I'm going to have to say for I in range 1, and then instead of specifying 10, because I know 10 is not going to be printed out, I'm going to say 1 to 11. And then I'm going to print out I. If I do that, I get 1 through 10, all 10 numbers. Okay, so that's basically the range function for you. One cool thing about the range function is its skip feature. Let's say that I want to print out all the even numbers, all the even numbers in the first 10 digits, okay? The way I can do that is using a skip function. For I in range 0 to, let's say 1 less than 11, so 10, and then 2, okay? So for I in range 0, 11, 2, colon, print I, I'm going to get 0, 2, 4, 6, 8, 10. What's really cool about this is how it's skipping the odd numbers. It goes from 0 to 2, 2 to 4, 4 to 6, and so on. The reason for that is because you specified the increment factor. Instead of always adding 1, if you leave it blank, if you just specify for I in range 1, 11, it's going to add 1 each time. But if you specify the increment factor like we did over here, and we're saying 0, 11, 2, we're adding 2 to each number. So it's 0 plus 2, 2. 2 plus 2, 4, 4 plus 2, 6, so on and so forth. So as a quick challenge for you guys, go ahead and print out the first 10 multiples of 5, okay? Pause the video right now if you want. Go ahead, try doing that. Okay, hopefully you guys did that. Should be pretty straightforward. You're gonna say for I in range 0, 51, 5, okay? So you're starting from 0 and you're working your way up. I'm gonna print out I, and I'm gonna get 5, 10, 15, 20, all the way up to 50. Awesome. So that's the core function of the range. It basically gets you a series of numbers, and you can specify if you want to skip, if you want to increment differently, so on and so forth. That's for loops in a nutshell. You use them to iterate over a data structure, whether it's lists or tuples or anything else, and you use them to iterate over numbers using the range function. One thing you guys can definitely play around with is using nested for loops. So I guess it's something like for I in range 0 to 5, for j in range, remember use different variables. For j in range 0 to 3, okay, I'm gonna print out I times j, or print out I times j, and I'm gonna get something like this. So you can use nested for loops to perform different functions, iterate over different, maybe multi-dimensional arrays, stuff like that. But that's the core concept of for loops. In the next lecture, we'll discuss while loops and dive deeper into how loops work, stuff like that. Hopefully you guys understood what for loops were in this lecture. Don't forget to like, share, and subscribe, and I'll see you in the next video. Hey guys, Avi here, and welcome back to your Python series. In this video, we're going to be learning about while loops and control statements. Both of them very, very important things in the field of Python, understanding loops, so on and so forth. Now, what are while loops? While loops are a type of loop that continue to run until the condition becomes false. They're very useful when you don't know how many times you're trying to iterate. Maybe it's 5 times, maybe it's 10 times, maybe it's dependent on the user. Basically, when that condition you have becomes false, then the while loop stops running. So I'm going to go ahead and create a counter called c, set it equal to 0. While c is less than 5, again, note the syntax, while, then your condition, then a colon. I'm going to go ahead and print out c, and then say c is equal to c plus 1. If you don't specify c is equal to c plus 1, then our c will remain 0. And 0 is always going to be less than 5, so this condition will always be true and will cause our computer, PyCharm, everything to crash. Okay? So always make sure that somehow, somewhere, your condition over here is becoming false. Alright? So that's basically while loops in a nutshell, guys. Very, very straightforward. Okay? You have a condition, make sure the condition is false, and the while loop will always run this code until the condition is false. What's more interesting, however, are the 3 control statements you use in loops. These 3 control statements are very useful in changing the path a loop normally takes. The first one is break. So let's go ahead and reset. C is equal to 0, while c is less than 5. Okay, I'm going to go ahead and print c. And then I'm going to say if c is equal to 3, break. So break is the first control statement we are learning today. Okay, so we have 0, 1, 2, 3, and then the code stops working. As you guys can probably tell, what does break do? It terminates the loop. So we have C1, C0, C1, C2, C3. When C is equal to 3, it breaks, so it terminates the while loop, and then this code stops running. So break is very useful when you've gotten the result you wanted, or you've gotten the output you needed, and now you just want to stop the loop. That's when you use break. The second statement is continue. You use the continue statement when you don't want the rest of the code in your while loop to run, but you want it to continue iterating. To give you an example, let's go ahead and reset. C is equal to 0, while C is less than 5. Okay, I'm going to go ahead and say if C is equal to 3, continue, otherwise print C, C is equal to C plus 1. Okay, I did make a mistake here, but I want you guys, just looking at this code, tell me what's going to happen. When C is equal to 3, 3 is going to be equal to 3. That's true. It's going to continue. It's going to skip all of this code. Then it's going to come back over here. 3 is equal to 3, continue, skip all of this code. It's going to be recursive, and our code is probably going to crash. Okay, so as you can see, it hasn't terminated, and our code is still running, and it's basically stuck in this loop. So what I'm going to go ahead and do is I'm going to stop this and restart this, okay? And let's go ahead and do that again, and I'll show you what I did wrong. So while C is less than 5, first we have to increment. The first thing we have to do is say C is equal to C plus 1, okay? And then we can say if C is equal to 3, continue, otherwise print C. Now what's going to happen is it's going to say 1, 2, hits 3, but when 3 is equal to 3, which is true, it continues, i.e. it skips this line of code and goes back to the top. Then it increments it, C is now 4, and then it prints out 4, then 5. That's continue. And last but not least, pass. Pass is by far, it's just a fun sort of statement you can use in while loops or in for loops. And basically what it does is you can say, while C is less than 5, C is equal to C plus 1. Okay? If C is equal to 3, pass, otherwise print C. So it works similarly. Okay, so what happened over here is the pass function is basically a filler sort of null statement, okay? It doesn't have any action, it doesn't do anything. It basically allows you to put in some filler code. If you don't know what you're gonna write, but you know there needs to be some code there, you can put pass, all right? So again, repeating the 3 statements, you have break, continue, and pass. The break statement is used in order to terminate the while loop or for loop. The continue statement is used to skip the remaining code and go back to the head of the loop. And the pass statement is a statement where you just have nothing. It's a filler sort of statement where you can put anywhere in your code just so that it looks nice, it looks neat, and maybe later on you can add some functionality to it. Recapping on while loops, just remember that the condition you have in your while loop must be false at one point in time, otherwise your while loop will become an infinite loop. Anyways guys, thanks for watching. Don't forget to like, share, and subscribe, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our Python series. In this video, we're going to be learning about the try and except case in Python, as well as how to comment our code. Let's get started. So the first thing we're learning today is the try and except case. Now, the reason why programmers use the try and except case is when you're running a piece of code where you're not sure if the results are going to be there, you're not sure if it's going to function right. Maybe you're calling data from a website, maybe you're calling an API, and you're not sure if that API is going to give you some data, maybe the API is broken. You want to put all of that code in a try and except case. Word for word, it's very straightforward. If the code in your try part doesn't work, it's going to default back to your except case. So let me go ahead and show you an example of how this works. I'm going to go ahead and say try, and then if name greater than 3. Again, we haven't defined name, so obviously this code is going to give us an error. If name is greater than 3, print hello. Otherwise, I want to say except print there's something wrong with your code. Please check again. Okay? So hit enter and we get there's something wrong with your code. Please check again. And the reason for this is because when Python was executing the try part of our code, it realized that, hey, name is not defined, this code is faulty, so it defaults back to the except case and it prints out the statement. So again guys, try and except, the concept itself is very, very straightforward. You're having basically an if and else. It's like, if this code works, that's great. Otherwise, if there's something wrong with this code, then go ahead, go to the except case and run that. So that's try and except. Now the second thing in Python is commenting. So if you guys don't know commenting is basically when you're writing a lot of code, you want to be able to put comments throughout so that any other programmer who takes over your code or any other person who sees your code should be able to understand what's going on. When you make big projects, you'll have a lot of functions, you'll have a lot of various things going on. So that's why it's always good practice to comment your code. So to do single line commenting, where it's just one line that you want to comment, you use Shift3 or the hash symbol. So this, and then you can go ahead and type whatever. This is a comment, and that is a comment in Python, okay? Now, you don't really use comments in console per se, but when you're writing code in files, for example, our hello world.py file over here, if I do something like this is a comment, that's perfectly fine. That's what we want to do. This is how you put comments in your files. The second way to do comments in Python, multiple lines, is using 3 quotation marks. For example, what I can do is I can say 3 quotation marks, and then I can say this is a comment, it's multiple lines, this is great, okay? So Python is taking all of these lines as a comment, each one as just one giant comment, and then I can go ahead and close my comment, putting 3 quotation marks. If I hit enter, I get this is a comment, it's multiple lines, this is great. While this output won't normally be there in a file, it's basically showing you how you can do comments in Python. I'll go ahead and do it here again. So you have 3 quotation marks, and then this is a comment. It continues. Hello. Okay. Just like that, where you put 3 quotation marks in the beginning, 3 quotation marks in the end, this is your multi-line comment. Anyways, that's it for this lecture, guys. I'll do a quick recap. Quite short. We had the try and accept case where you try something out. If your code works, that's great. If there's a bug, if there's an error, then it goes to the accept case and it runs the accept case. Second of all, commenting. With commenting in Python, you use a hash sign or Shift3 for single line comments. And then for multiple line comments, you use 3 quotation marks, write your code or write your comment, and then 3 quotation marks to end it. Anyways, hopefully all of this made sense to you guys. Don't forget to like, share, and subscribe, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our Python series. In this video, we're going to be learning about functions. Functions are basically the essence of any programming language. They allow you to reuse your code more efficiently, and they save a lot of space and a lot of time in your code. For example, let's say we have a piece of code, maybe it's a print statement, maybe it's a for loop. You're running it multiple times. You have the top of your code, you have it in the middle of your code, you have it at the bottom of your code. Instead of doing that, what you do is you take that code, put it in a function, and then you call that function wherever you needed to call that code. Very simple, very straightforward, but its use case is widespread. So that's why, guys, today we're going to learn about functions. Now, how do we create a function? In Python, it's very straightforward. You type def, which is define, okay? And know how I'm typing in my hello world.py file and not in my console. Could I do this in my console? Sure, absolutely. But I want to show you in the file because it's just a bit easier, just a bit more fun to do. So go ahead and say def, and then your function name. So our first function is just going to print out hello world. So I'm going to call this hello world. And then at the end of every single function name, you have to put in 2 brackets. Okay? This basically signifies that either it's an empty function, or you can pass in parameters into this sort of brackets area, and you can specify that the user must enter some parameters to call this function. Right now, our hello world function is just a print statement, so we don't have to pass in any parameters. So def hello world colon. And now here comes the code part. What code are we putting this function that's going to be reused in multiple places? Well, for us, it's just going to be print hello world. Okay? So that's it, guys. That's our first function. Now, if I run this, nothing's going to happen. There's no output. And the reason for this is because we're not calling a function. Creating a function is great. You know, you can create multiple functions, define as many as you want, but you still have to call them. The way you call functions is by saying hello world and then the brackets. This calls the function, which will in turn print out hello world. So go ahead and save this, and we get hello world. Awesome. Now let's go ahead and create a function that takes in the user's name and prints out hi and then the user's name. So in this case, define, I'm going to call my function greeting. And then inside of these brackets, we need to specify the user's name. Now, if you're coming from Java or Swift or another programming language, you know that you have to specify the type of variable it is. Is it an int name? Is it a string name? Is it something else? Like, what is the data type of this variable? But in Python, you don't have to specify anything. That's why Python is such an easy language. All you have to do is just say name. That's it. Python will take care of the rest. Now Python knows that we have to pass in a name in our greeting function. So hit colon, print hi plus the name. I'm going to put a space there and then an exclamation mark. Great. So that's it, guys. That's our greeting function. And let's go ahead and call this. So greeting, but greeting now needs a name. So I'm going to go ahead and say Avi, save this, run, and we get hi Avi at the bottom. Great job. Now, as a quick challenge for you guys, I want you to create an addition function. Pass in two numbers and print out the sum of those two numbers. Go ahead and pause this video, try it out. All right, hopefully you guys were able to do that. Again, very straightforward. Go ahead and say def add, and then in the brackets, you want to specify num1 and num2. Remember, we don't have to specify any data type, anything, just the variable names. And then we're just going to say print num1 plus num2. Awesome. Let's go ahead and call our add function. Let's say 10 and 15. Output should be 25, and we get 25. Fantastic. So that's functions for you in a nutshell. And before I end this video, I want to show you the return statement, what the return statement does in a function. So let's say that we had this add function, but instead of printing it out, I want to store this value somewhere. So I'm going to call this return add. Okay. And instead of saying print num1 plus num2, I'm going to return num1 plus num2. So you might be confused as to what exactly does the return statement do? Well, what it does is we can now associate this value, num1 plus num2, to a variable. And now what we're going to be doing is we're going to go ahead and associate this return to a variable. So I'm going to call this sum, and sum is going to be equal to return add of, let's say, 12 and 23, or 34. Let's go ahead and print out sum, and let's see what we get. So run this, and we get 46. Fantastic. So hopefully return makes sense to you guys. Return allows us to send back a value with our function. Most functions, you may want to print something out, you may want to evaluate something, but once you evaluate that, you need to return back that value originally to wherever you call that function. And the way you do that is by calling the return statement. Note, if I say return num1 plus num2 here, and then I say print hello, okay? And if I run this, I'm not going to see hello, because once Python encounters a return statement, it does not move on to the next code. After Python sees the return statement, it ends the function, goes back over here, returns the sum, which was 12 plus 34, 46, sum is now 46, and print hello never gets executed. So that's functions for you guys, okay? Again, functions are blocks of code that you throw in under a function and then you can reuse multiple times. To create a function, you use the def keyword, the function name, and then brackets in which you can pass in parameters. Remember, don't forget your colon, and then underneath the function, you have your various code. To call a function, you call the function name, plus the brackets, and any parameters you might need. Awesome job, guys. Hopefully functions made sense. Yes, they're a bit complicated, but honestly, once you get them, you'll be using functions everywhere. Thanks for listening, guys. Don't forget to like, share, and subscribe, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our Python series. In this video, I'm going to be teaching you guys the various inbuilt functions in Python. Now, in the last lecture, we discussed how to make our own functions, but Python has tons and tons of functions you can use with various data types, and I'm going to cover just a few of them just to get your hands dirty and understand what are some of the functions that exist. So let's get started. The first function I'm discussing is going to be the absolute function. That is ABS and then parentheses. Inside the parentheses, you pass in a number, and absolute value works just like the mathematical statement. It takes any positive or negative number and makes it positive. So absolute value of 34 is 34, absolute value of negative 23 is positive 23. Again, it's a mathematical function. Just for you guys' reference, absolute value is known as ABS in Python, and you can call it on any negative or positive number to get the positive version of that number. Awesome. The second function we're learning is the bool function. The bool function takes in any number, and if the number is 0, it returns false. Otherwise, in any other case, it'll return true. So bool of 0 gives me false because Boolean values are zeros and ones. Any other thing, so bool of 1, bool of 100, anything else you do, it's always going to be true. And 0 and none are very similar. So if I do bool of none, again, none is basically blank, nothing exists. It's like 0, then you get false as well. So the bool function is used to basically check to see, hey, is your value a 0 or is it a 1? It's very effective in using that sort of that bool condition as you might have seen in Boolean code. The next function we're going to learn is the dir function. And the dir function basically tells us all the various functions you can use with a specific item. For example, let's say we have a string. I want to know what all can I do with a string. So I'm going to go ahead and say dir hello. Again, this string could be anything. And then it gives me a list of all the various things I can do. I have all these different functions. There's join, lure, title, strip, split lines. There's a whole bunch of stuff. So dir is very useful when you have a specific data type or you have a specific object and you want to figure out, hey, what function exists? Is there something that Python has that I can use? Now let's say that I wanted to uppercase all the letters, okay? I have this function over here. It's called upper. But I want to know, what does that function do? Does it uppercase the first letter? Does it uppercase all the letters? I want to find out more about this function. That's where the help function comes in. The help function tells us, hey, what's going on? Does this actually work? So I'm going to go ahead and store hello as a sort of sentence. Sent is equal to hello. And then I'm going to go ahead and call help sent.upper. Okay? So again, very straightforward. The help function takes in a function name. So basically, instead of calling upper, we call the data type or the data object and then the function. And if you enter, it tells us what it does. The upper function basically takes in the string and it returns a copy of s converted to uppercase. Awesome. So that tells us, hey, that's what the upper function does. If I want to find out, okay, looking over the functions, what does split lines do? So sent.splitlines. Hit enter. And split lines tells us returns a list of lines in S breaking at line boundaries. Awesome. So that's the help function for you guys. It's very, very useful when you're looking at the dir, the return value of dir, and you're trying to figure out, is there a function that works? Or in general, if you're ever confused about something, just run the help function on it to figure out what's going on. Awesome job, guys. Just a few more functions. We have eval and exec. The eval function is used to basically run Python code in a string format. For example, if I have a string, let's go ahead and make sent to a string. Sent is equal to print hi, okay? So that would work in Python if I just done this, print hi. Actually, would it? No, I would need quotation marks. So let me go ahead and add quotation marks. And I'm gonna go ahead and do single quotes outside so that Python knows what I'm doing. Awesome. And then I'm gonna go ahead and run eval of sent. And that gives me hi. So what the evaluate function does is it takes the string, it takes in your string, and it runs it as if it were Python code. So if you maybe have a text document of Python code, or if you wrote it in a doc, and you get that doc into your Python code, and you want to run that code, you would use eval or you would use execute. So exec, on the other hand, is very similar. It does the exact same thing, but execute is more for complicated code. If you have multi-line code, multiple lines of code, you'd use execute instead of evaluate. Evaluate is more likely used for something that's, one line, something very straightforward. What is 5 times 3? 15. Okay? So that's evaluate and execute. Evaluate for one line strings that are basically Python code, and execute for multi-line Python code. Awesome job, guys. Just a couple of more. To finish it off, we have string, int, and float. So we discussed data types in the first few lectures of this series, and we understood that, hey, there's strings, there's integers, there's floats, a whole bunch of that. But how do we convert from one data type to another? For example, let's say we have an integer, okay? A is equal to 1. I want to string it. I want to make it into a string instead of an integer. I'm going to call str of a. That gives me it in the string format. If I want it in a float format, I'd call float of a, and that gives me 1.0. And if I want the normal int format of it, I just call int of a, and that gives me 1. So these are the 3 functions you use to convert between string, float, and integer. And maybe you want, print it out maybe you want to print out a statement as a string. Maybe you need a float to do some decimal division. Doesn't matter what it is, but these 3 functions exist to convert between different data types. Okay, so let's do a quick recap of all the functions we learned. I'm going to go ahead and quickly list them down here. First one is absolute. Absolute value function takes in a number. If it's 0 or none, it's going to return false. Anything else, it's going to return true. Oh, I'm sorry. Bool is that. Absolute value takes in any number, and based on if it's negative or positive, it's always going to return positive. Boolean, on the other hand, will take in 0 or none, and will always return false. Otherwise, it's always going to return true based on anything you put in. Going back over here, we have directory. Directory gives you a list of all the functions related to the specific object you passed in. Help will tell you what the function does, what the method does, based on what you pass in to the help parameter. Then we had exec and evaluate. Evaluate for single line codes, execute for multi-line lines of code. And then we had string, float, and integer. String, again, you use a string to convert from an int or float to a string. You use float to convert from a string or int to a float. And you use int to convert from a string or float to an int. Again, all these functions are very common, very straightforward, and hopefully all this made sense to you guys. Anyways, thanks for listening. I'll see you in the next lecture, and don't forget to like, share, and subscribe. Hey guys, Avi here, and welcome back to our Python series. In this video, we're going to tackle object-oriented programming. Every programmer, no matter what language you learn in the future, no matter wherever you go, object-oriented programming is going to be one of the most important skills you should know. Any code you write, any project you make will have some aspect of classes and instances that you'll be using, and it's always good to understand how that works, and this lecture will hopefully cover all of that. So let's get started. Now, classes in Python are very straightforward. Object-oriented programming in Python consists of two main sort of categories: classes and objects. Classes are the overall type. They're a category. They could be person, forest, animal, cars. It's broad. It's supposed to be vague. And then from that class, you get objects. Objects are an instance of that class. If I have a person class, let's say, and I want to create an instance of that person class, I would create a new object, okay? And that object could be Avi, it could be person 1, it could be person 2, it doesn't matter. But you create an object of that class, and that becomes an instance of that class. So enough of me trying to explain. Let me go ahead and show you an example. So go ahead and in your console, type class person : So this goes ahead and creates our person class. And for now, I'm just going to say pass. Again, remember we learned pass a couple lectures ago. Pass basically is a filler. It basically means that, hey, we're leaving it blank for now. We'll add more stuff later. But this is a working class. Now I want to go ahead and create an instance or an object of this class. The way you do that in Python is you give it a variable name. So I'm going to go ahead and call the instance of my class P and set this equal to person and then brackets. So P is equal to person brackets, hit enter, and now P is an object of the person class. Okay? So if I hit P, I get person object at some number. Fantastic. So that is the most simple class you can make. Now, in Python, Python uses something known as self. If you've used Java or C#, you know this when you say like this dot some method, this dot some value. In Python, we use self. And any function you have in Python, no matter if it has any parameters or doesn't have any parameters, you still have to pass in the argument self. Self refers to the current object you have or the current instance that you have. So self in this scenario would refer to P, the P object I have right now. It refers to itself. So I'm going to go ahead and recreate the person class. And I'm going to go ahead and define a couple of methods. I'm going to say def get name. And then in here, even though we don't have any parameters, you still have to pass in self. Okay? So hit colon, and then I'm going to print out Avi. And then I'll do one more, and I'll say def get age, pass in self, and print out 16. Awesome. So again, functions are very straightforward. We covered them a couple of lectures ago. Def get name, again, we're creating a get name function, passing in the self parameter, and then printing out Avi, printing out 16 based on the function. So hit enter. Now let's go ahead and create a new person object, again calling it P. And now I can go ahead and call various functions of this object. So I can say p.getName, Avi, and p.getAge, 16. Awesome. So again, note how we pass in self. What self does is it tells the class which object is performing this function? Which object am I trying to perform this function on? So the way I want you to think about it is when you pass in self into this function, it basically means that we're calling the method person.getAge, and inside of this we're passing in the object, which is p, and then that's it. Since there are no other parameters, this is basically the function we're passing. So that's self for you in a nutshell, and that's how you create functions in a class. Now, one last thing I want to cover is the initialization function. The init function in Python allows us to create an object of the class with specific properties, specific attributes. Right now, our person class is hard-coded. Every person who's created has the name Avi and the age 16. What if I want to change that? The way I can change that is by using an init function. The init method is called right when you create the object, and it takes in the parameters you passed in and it assigns them to the variables in the class. So class person def, and then instead of just typing init, you're going to type 2 underscores, so not just 1 but 2, init, and then 2 more underscores. Okay, so you should see this purple highlight, again 2 underscores, make sure you're not typing 1, it's 2, then init, and then 2 more underscores. Awesome. And then we're going to pass in self like any other function, but now we can pass in different parameters. So in the case of ours, we had age and name. So I'm going to go ahead and say name and age, and now colon. Now we have to associate the parameters that are passed in and actually store that. So the way we do that is we say self.name is equal to name, self.age is equal to age. I'll explain this code in just a second. And now what we're going to do is I'm going to go ahead and create a function getName, pass self, and instead of just printing out Avi this time, I can go ahead and say print your name is, and then I'm going to go ahead and say self.name. And the exact same thing I'm going to do with getAge, pass in self, and I'm going to go ahead and print out your age is, and then self.age. So go ahead and get this code down. Again, we have 3 functions now. We have an init function, we have a getName, and we have a getAge. Hit enter, and now our person class has been created. So let's go ahead and call this P1. P1 is equal to person, but now we have to pass in a name and an age. If we just call P1 equal to person, we get an error, which says that, hey, your init function takes in 2 required arguments. So P1 is equal to person, and now let's go ahead and say Bob, and let's say he is 22. Okay, it doesn't matter. So P1 is equal to person, Bob, 22. And now if I go ahead and say P1.getName or getAge, I get your age is 22, and P1.getName is your name is Bob. Fantastic. So hopefully that made sense to you guys. What the init function does is it takes in parameters that you want to pass in when creating the object. That could be anything you want, any parameters you need to create the object of that class. And then to store those parameters, to store those arguments, you say self.the variable name. Again, this is name, okay? I'm passing in name, but I could have said self.end, self.anything. But whatever I store that attribute as, then anywhere else in my class, I can call it. So when I first create the person object, I say self.name is name, self.age is age, and then later on in these 2 functions, I go ahead and recall the name and the age of that person class, of that object that was created. Anyways, awesome job, guys. That was the basics of object-oriented programming. Again, remember, it's 2 different sections. You have classes and objects. Classes are the overall duplicator. It's the duplication machine. You're allowed to create a structure, and then the objects are instances of that structure. So I could have a class car, and then I could create various cars, a Bugatti, a Chevrolet, a Ford. Doesn't matter, but basically, that's how classes and objects work. In the next few lectures, we'll cover more about these, understand some various concepts in object-oriented programming, and hopefully at the end of this series, you will have understood object-oriented programming to what it is. Thank you so much for listening, guys. Don't forget to like, share, and subscribe, and I'll see you in the next video. Hey guys, Avi here, and welcome back to our Python series. In this video, we're going to be continuing our object-oriented programming, but we'll be learning a new concept, and that concept is inheritance.
Now, with classes and object-oriented programming, many times you'll have one class that falls underneath another. For example, we might have a class person, and underneath that we might have another class male and female. Or you might have divided it into age sectors, teens, adults, old people, stuff like that. So in inheritance, the concept is that you have a child class and a parent class. And the child class inherits, which means that it gets all the properties and functions of the parent class. Okay? So again, it might be a bit confusing, but let's go ahead and let's create an example parent class. So I'm going to go ahead and say class parent, and I'm going to create an init function, pass in self, and I'm going to go ahead and say print out, this is the parent class. Okay? And then I'm going to create a parent func, or a parent function, pass in self, and print, this is the parent function. Okay, so let's go ahead and hit enter. That's our parent class. If I go ahead and create a p object for parent and initialize it, so p is equal to parent, that is fantastic. I immediately get this is the parent class. Awesome. I can go ahead and also call the parent function parent func p.parent func, and I get this is the parent func. Awesome. So that again is just the parent class. We haven't done anything new. Now we're gonna go ahead and create a child class that inherits the parent class. So I'm gonna go ahead and say class child, and now to show that one class inherits the other, what you do is after you type the class name, you put in brackets the parent class, which in this case is called parent. So class child of parent, okay? So we're basically saying that child inherits parent. Now we're gonna have our own init function. In itself, print, this is the child class. And now I'm gonna go ahead and create a child function, self, print, this is the child function. Okay? Awesome job. So now we have our child class, and our child class has an init method and a child function. Print, this is the child class, print, this is the child function. Awesome. So I'm going to go ahead and create a child now. So C is equal to child. And I'm going to go ahead and hit enter. And I get this is the child class. I can now call a child function as well. And I get this is the child function. But what happens when you inherit is that you also get all the functions in the parent class. So what I can do now is as a child object, I can call c.parent function. And that will get me this is the parent function. And the reason why this works is because when we create the child object, this child object has the functions of the parent class as well. That's the whole point of inheritance. If you have an overall function, for example, every person eats, every person has an age, every person has a name, all that will go into the person class. But then you have specifics. Maybe you have it divided by age, where the age differs. Maybe you have it by gender, where the gender differs. In that scenario, you have a bunch of functions that can be in the parent class, and then you can change it up in the child classes. So that's inheritance for you. Now, the last thing we'll be learning in this sort of object-oriented programming is overriding methods. If I have a parent class and I have a child class, and both of them have the same functions, how do I tell Python that, hey, I want to use the child function method, not the parent function method? So let's go ahead and understand how to override methods in Python. So I'm going to go ahead and create the new parent function again. Def init, self, I'm just going to go ahead and pass for now. And then I'm going to create, I'm going to call this function test, pass in self, and print just parent for now. Okay. So that's again a simple parent class, and if I create a parent object and call p.test, I get parent. Great. Now I'm going to do the exact same thing with child. Again, let's make sure that we're inheriting the parent, and create the init function as we did before, and pass, but
I'm also going to create a test function for my child class. So def test self print child. Okay? And now if I create a child object, what do you think is going to happen when I call c.test? Go ahead and run this if you want, but let's go ahead and understand the actual working of overriding methods. I have a parent class. My parent class is a test function. It's supposed to print parent. I have a child class that inherits all of my parent class functions. So I have a test function that's supposed to print parent. However, I reinitialized that test function over here, and now I'm printing out child. In Python, when you reinitialize a function in the child class, that is going to replace the parent function. So this def test self print parent gets replaced by the print child. So c.test gives me child. That's the whole point of overriding the method. If I have a function in my parent class and I want to override in my child class, I just have to reinitialize it, just call it def test self, and then whatever code I put over here will override the code in my parent test function. Alright guys, that's it for this lecture. Thanks so much for listening. Don't forget to like, share, and subscribe. Hopefully, object-oriented programming made sense. Again, it's very straightforward, very simple. Just remember there's classes, there's objects, and an object is an instance of a class. Anyways, thanks for listening, and I'll see you in the next video.